Zadie lives in Chicago and decides to go on vacation, so she gets on a plane and flies 200 miles. Where did she end up? You can't know where she ends up without first knowing what direction she flew in, right? This is an example of a vector, which is a quantity that has both a magnitude and a direction. In order to know where Zadie went on her vacation, you need to know both how far she went and in what direction. Many other physical quantities, such as force, velocity, and momentum, are also vectors. Vectors may be either two-dimensional or three-dimensional, depending on the situation. One way to represent a two-dimensional vector is with vector components, which simply tell you how far the vector goes in each direction. For example, a vector with an x component of 4 and a y component of 3 that started at the origin would end at coordinates 4, 3. The magnitude of a vector is the total amount of the quantity represented by the vector. For a two-dimensional vector, the magnitude is equal to the length of the hypotenuse of a triangle, in which the sides are the x and y components. Therefore, if you know the two components of the vector and want to find the magnitude, you can use the Pythagorean theorem. You can also use the tangent function to find the angle that the vector makes with the x-axis. For the vector shown here, the magnitude would be 5, and the angle it makes with the x-axis would be 37 degrees. Three-dimensional vectors are just like two-dimensional vectors, but there's just one more direction to keep track of. Just like two-dimensional vectors, you can represent a three-dimensional vector using the three components in each of the three directions. There are a few different ways that you might see a three-dimensional vector written. Sometimes you may see the three components written inside brackets like this. Other times, the components of a vector may be designated using the unit vectors I, j, and k, which simply show which direction each component is in. I represents the x component of the vector, j represents the y component, and k represents the z component. You may see this notation for two-dimensional vectors, but it's even more common for three-dimensional vectors. You can find the magnitude of a three-dimensional vector in much the same way as we did for a two-dimensional vector. Just as the magnitude of a two-dimensional vector is calculated using the Pythagorean theorem, you can do something similar for a three-dimensional vector. The magnitude is equal to the square root of the x component squared plus the y component squared plus the z component squared. For a vector with components 6, 2, 7, the magnitude will be r equals the square root of 6 squared plus 2 squared plus 7 squared, which equals 9.43. You can add and subtract three-dimensional vectors in exactly the same way that you add and subtract two-dimensional vectors. You just have an extra component to work with. To add any two vectors, simply add the two x components, the y components, and the z components. Be careful to keep the components separate because they're all in different directions. For the two vectors, a and b, shown on your screen here, you can find their sum by adding each set of components. To subtract two three-dimensional vectors, just do the opposite and subtract each set of components. Let's take a moment to review what we've learned. A vector is a mathematical quantity that has a magnitude and a direction. Vectors can be either two-dimensional with components in the x and y directions, or three-dimensional with components in the x, y, and z directions. Both three-dimensional and two-dimensional vectors can be represented by components in each direction. To add or subtract both two- and three-dimensional vectors, simply add or subtract each set of components.